Okay, so now we're going to look at fractions. Okay, now I know fractions are everybody's favorite. That's why we're going back and we're going to look at all the basics of fractions, because we are going to do a lot of work with fractions in this entire course. Okay, and typically our fractions are going to have variables, and we're going to have expressions divided by expressions. Those are called complex fractions. So we're going to do a lot of fraction work this year. So we're going to start off with just the basics in fractions to make sure we remember how to work with fractions, add them, subtract them, multiply and divide, all that fun stuff. So we'll start off by naming things. This top part here is called the numerator. Okay, and I know a lot of this stuff you're probably very familiar with, but this is just in case we have forgotten. We want to make sure that we understand all this stuff. The bottom part is the denominator. You really need to know those two words, because when I'm speaking and we're talking about theory and things like that, if I'm talking about the denominator, you need to know that that's the bottom. Okay, when you're multiplying two things together, each one of these is considered a factor. Okay, so 3 times 5, those would both be factors, and multiplication, of course, yields a product. Okay, so when I'm factoring things, each one of these little things is considered a factor. We'll do factoring a lot later, but those are considered factoring, the pieces that you multiply. All right, so a fraction is said to be simplified, or in lowest terms, when the numerator and denominator have no common factors besides 1. So, for instance, if this is my factor, so if I break 15 down into 3 times 5, those would be the factors. So as long as the top and bottom, or numerator, denominator, don't have any common factors, so if they both have 3, it's not simplified. Okay, so that's kind of what you're looking at. So to help us, we can use something that we call the prime factorization. This is what we're going to use to help simplify our fractions. Okay, so we're going to simplify them by using a prime factorization, which is the process, is also known as called product of primes. Okay, so basically if I can break something down into the product of primes, then I can determine whether or not the numerator and denominator have common factors. So basically what the product of primes would be is if I had 15, okay, well I can break 15 down into 3 times 5. Well, 3 is a prime number, 5 is a prime number. Remember, primes are, they're only divisible by 1 in themselves. So 1, 3, 5, 7, 11, those are your prime numbers. Okay, those would be examples of primes. And it continues on. People think that it continues on infinitely, but it hasn't been proven that it's infinite yet. But it's assumed that it is going to be an infinite set. So that's what breaking things down into the product of primes. And I'll show you how to do that in just a second. All right, so prime numbers, which is what this just says, a whole number other than 1 whose only factors are 1 and itself. Okay, so here let's list out the first few. Okay, 2 is a prime factor, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Okay, and it keeps on going from there. Okay, those are your prime numbers. So if I can break them down into these prime numbers so that it multiplies out to whatever I'm trying to get to, that would be a product of primes. Alright, so for instance, find the product of primes, okay, or prime factorization of the following. So you need to recognize that when we say product of primes, we mean break it down into its most simple form. Okay, now an easy way to do that is to just go with some easy numbers. So for instance, 40. Just think of what two numbers multiply to 40, okay? Well, 4 times 10. And there's other ones. I could have done 8 times 5. That would work also. You're going to get the same product of primes no matter how you start. So don't worry about which ones I start, as long as they multiply to 40. So 4 times 10 is 40. Okay, well 4 breaks down into 2 and 2. 10, 2 times 2 would be 4, that's why that breaks down. Okay, 10 can break down into 5 times 2. Okay, Well, each of these is prime. 2 is prime, 2 is prime, 5 is prime, 2 is prime. So this is the product of primes. So 2 times 2 times 2 times 5. 2 times 2 times 2 times 5. And it doesn't matter if you do 5 times 2 or 2 times 5. Okay, but this right here would be my product of primes. Because if I multiplied 2 times 2 times 2 times 5, I would get 40. Okay, so that's considered to be a product of primes or a prime factorization. Okay, so do the same thing here for 63. So just start with two numbers that you know multiply to 63. Doesn't matter what you choose. I'm going to go with 9 and 7. You could have gone 3 and 21 would work. That would give me 63. However you can find it to break it down. So I'm going to start with 9 and 7. Okay, so 9 breaks down into 3 and 3. 7 doesn't break down at all. It's already prime. So there's my primes, 3, 3, and 7. So 3 times 3 times 7 would be my answer. Okay, that would be the product of primes, because I multiplied 3 times 3 is 9 times 7 is 63. Okay, product of primes. Okay, so now we're going to look at what we consider to be the simplifying rule. Okay, the simplifying rule. And you might want to write that here. I'm not sure if it's on your paper or not. Now, your paper might look a little bit different than the way mine does. Okay, your paper's probably, oops, helps if I spell simplifying correctly. Can't talk and write at the same time. Okay, simplifying rule. Yours should already say simplifying rule, and yours is going to look a little bit different than my paper here, but it's going to be the exact same thing. So we're going to start with the simplifying rule, which says that if I have A times C divided by B times C, then that's equal to A over B. Now notice this is multiplication, A times C and B times C. This does not work if it's A plus C and B plus C. That's different. And we'll talk about that later. But if I have A times C over B times C, then those C's essentially just cancel out. And I end up with A over B. Okay, because you got to imagine that if I multiply something by 2 on top and on bottom, well, I'm dividing the top and bottom by that same number. So 2 divided by 2 is just 1, so that kind of cancels out and goes away. That's what happens. Okay, this same thing is saying A over B times C over C, which is 1. Okay, so that's kind of where that comes from, and that's the rule, though. Okay, and this only, again, works with multiplication. So write the fractions in lowest terms. Okay, so if I'm going to write the fraction in lowest terms, I'm going to start by writing these things in their prime factors. Okay, so if I go to the product of primes, just like we did up here, so look at 42. Okay, what multiplies to 42? Okay, well, I've got 6 times 7. Okay, that's 42. 6 breaks into 3 and 2. Those are all my primes. So I've got 3 times 2 times 7 on top. Okay, and then what about on bottom? Well, 49 breaks into 7 times 7. Okay, well, that's it. 7 and 7. That is my product of primes. Okay, so by definition, in the very beginning, we said that a fraction is in simplified or lowest terms when they no longer share a common factor. Okay, so that's what we're looking for, is do we have common factors? Well, here we do. We have a 7 and a 7. Now, notice I only cross out one of them. Okay, I cannot cross out 1 7 with 2 on bottom. You have to exactly match up. So I've got 1 7 in common here, so those cancel out, and that's it. So then you just multiply out the rest. So 3 times 2 is 6 over 7. Okay, so that's what that's going to look like. So for instance, on B, okay, when you look at B, I've got 11 over 27. 11's already prime, so 27, let's break it down. 9 and 3, 3 and 3. Okay, so I've got a bunch of 3's on bottom, so on top I've got 11, and that's prime. And I've got 3 times 3 times 3. Well, there are no common factors anywhere. 11, 3, 3, and 3. Okay, you can't cross out 2 on the bottom. That wouldn't make any sense. It only works if you cross out with something on top. Okay, it's not a common factor if they're on bottom. So 11/27 is my lowest term. Okay, it can't reduce. Okay, so my answer would just be 11/27. If they said write it in lowest terms, well, 11/27 is the lowest term, so that is my answer. Okay, now I would suggest you go ahead and hit pause, try this last one, come back, see if you can get the same answer as I do. Okay, if you did that, and you were coming back 88 can break down many ways. Okay, I could start by it's even, so I could divide it out by 2, or you could recognize that it's a double number, so 8 and 11. Okay, 11's already prime, so if 8 breaks into 4 and 2. Now you'll see me a lot that I'll cross out a number when I'm done with it. Okay, reason being is because otherwise it gets kind of confusing. You end up with all kinds of numbers all over the place. So if you kind of cross it out once it's been split, it makes it a little bit easier to see what you've done and what you haven't. So 4 breaks into 2 and 2, and I'm done with that 4. Okay, so on top I've got 2 times 2 times 2 times 11. Okay, and let's do the same thing for the bottom. So 20, we can go to 4 and 5, or 2 and 10. Again, you're going to end up in the same spot. 4 breaks into 2 and 2. Okay, so on bottom I've got 2 times 2 times 5. So I'm breaking into prime factorization, and then we're going to cancel out. So 2's cancel, 2's cancel. It's got to be a perfect 1-to-1. I can't just cancel them all out. Okay, 2 with 2, 2 with 2. And then I've got 2 times 11 is 22 left on top, and 5 left on bottom. Now you don't have to worry about mixed numbers just yet. We'll talk about those later on. Okay, so 22 over 5 is what you should have gotten for an answer there. Alright, so now let's look at how to multiply fractions. Okay, so our multiplying rule, I've got A over B times C over D. Okay, well when I multiply fractions, I literally multiply straight across the top and multiply straight across the bottom, B times D. So that's just AC over BD. Okay, you just multiply straight across the numerator, straight across the denominator. Okay, that's multiplication. So for instance here, okay, when I multiply them, now it wants me to write it in lowest terms, so I'm going to show you a little trick that'll make your life a whole lot easier. Okay, my suggestion here is once I multiply them across, I'm going to end up with 2 times 5 over 15 times 13. Now, I'm not going to multiply 15 by 13 just to turn around and find two numbers that it multiplies to. So basically, when you're thinking about the prime factorization, so say here 27 breaks into 9 times 3, well just consider they already did that first step for you, 15 times 13. Okay, they already did that first step, so now we're just going to complete the prime factorization from here. So 15 can break into 5 times 3, and that's prime. 2, 5 on top, 5, 3, and 13 on bottom. Okay, so now just cancel out anything that matches up. So I've got a 5 and a 5. So on top I'm left with 2. On bottom, notice I'm multiplying, so 3 times 13 is 39 on bottom. Okay, so that's one such method where I write them together and then do my prime factorization. Now most of you aren't going to want to write that extra step, and I am perfectly okay if you do it from right here. Okay, I highly suggest that you be very careful and you stay very neat, because if you get sloppy here, you tend to lose numbers, so be very careful with that, and I'll show you my suggestion here. So 10, start with the 10, let's break them down from right here. So 5 and 2. I highly suggest you cross out the ones that you've already broken down. So 9 breaks into 3 and 3. That 9 is done. 27 here breaks into 9 and 3. 9 breaks into 3 and 3. Again, I'm doing the crossing out just because it makes it a lot easier for me to go back and tell what all I have. And 25 breaks into 5 and 5. Okay, now I'm going to warn you to be very careful about these little guys that are way up here. They tend to disappear if you're not careful, so make sure you're paying close attention to what you actually have. Alright, so the 5's gone. Okay, 1 5 on bottom, 1 5 on top. It doesn't matter if it's the left one with the right one, because if I were to write them all together, they'd all end up on top over the ones on bottom. So it doesn't really matter if I cancel across. All that does matter is it's got to be top with bottom. Okay, that's one of the most important things about the multiplication, is when I simplify, it has to be top with bottom. I cannot do tops together just because they're in left and right. That doesn't work, or bottoms left and right. It has to be top to bottom, top to bottom, top to bottom. Okay, so 5's top and bottom. I've got a set of 3's top and bottom. I got another set of 3's top and bottom, and that's it. I've got a 2 left on top right here, and I've got a 3 and a 5 left on bottom. So 3 times 5, which is 2/15. Okay, again, nothing really on this is really all that difficult. The big part is going to be making sure that you stay very, very consistent. Okay, stay very consistent, or not staying very consistent, staying very neat with your work to make sure you don't accidentally lose numbers, because that's usually what people do, is they forget that there was a 2 up here because it kind of gets mixed in with all the scribble. Okay, so make sure you're very clear when you are writing these. Okay, so now the dividing rule, and again, your paper probably looks a little bit different than mine does, and that's okay. Just make sure mine looks really different because we're missing dividing. Okay, dividing fractions. So when I talk about dividing fractions, okay, if I have something like A over B divided by C over D. Well, that's the exact same thing as saying A over B times D over C. This is something we call KFC. Keep it, flip it, change it. Okay, some of you may have heard it KCF. Keep it, change it, flip it. Okay, I do KFC just because KFC is easier for me to remember because I like KFC. Okay, so KFC. So keep it, flip it, change it. So what happens is the first one we keep. A over B is still A over B. The second fraction we flip. C over D becomes D over C. And then we change this to multiplication. So A over B times D over C is how that works. Okay, so keep it, flip it, change it. Keep it, flip it, and change it. Okay, so we are going to KFC these things. That's how that's going to work. So divide and write in lowest terms. Okay, no problem. It's the exact same thing as we just did for multiplication, only you must KFC first, and that's super important. Okay, you must KFC first. Okay, so before you start canceling anything, KFC must happen first. Okay, so 3/8. Keep the first, flip the second, so instead of 3/10 it becomes 10/3, and then we change it to multiplication. Okay, so now that I've done the KFC, now I can reduce these things. So 8 becomes 4 and 2, which becomes 2 and 2. 10 becomes 5 and 2. Okay, now just go through and reduce everything. So I've got 3 and a 3. I've got a 2 and a 2, and that's it. So what we have left is a 5 on top and a 2 times 2 on bottom, which gives me 5/4. Okay, so 5/4 is what you end up with there. Now I would go ahead and hit that pause button, see if you can't try this. Keep in mind that if I have a whole number, I can always put it over 1 to make it a fraction. Okay, so hit pause, give this one a try, come back, see if you get the same answer as me. Here we go. Okay, so I get KFC first. Keep the first. Flip the second. So now it becomes 1 over 14. Change its multiplication. Okay, when we start to break these down, so 10 breaks into 5 and 2. 14 breaks into 7 and 2. So we're going to get rid of the 7 and the 7. So what I'm left with on top is just a 1. Now keep in mind that even if no matter what happens, you should always have at least a 1 left. Okay, because when I cancel 7 and 7, technically I'm saying 7 divided by 7 is 1. So realistically I have a 1 and a 1. We don't typically write it though because 1 times 1 times 1 times 1 is just itself. So we don't typically write the 1s. But if everything on top were to cancel out, there's at least a 1 there. Okay, so you have to keep the 1 to show keep the numerator spot so that you know that this stuff is in the denominator. So 5 times 2 times 2, that's what I've got, 1, 2, and 3. 5 times 2 times 2. So we're going to get 1 over, 5 times 2 is 10, times 2 is 20. So 1 over 20 is what you should have gotten. Keep in mind that when we're doing this unit, I will not accept decimals at all. So if you're just tossing these things in your calculator and you're getting decimals, that's not going to work because you're not going to get a calculator for this section. So please keep that in mind. You will not have a calculator on this test. All right. So now on to adding and subtracting. Okay, so when we add and subtract fractions, okay, you must, absolutely must, notice the big bold there, you must have a common denominator. Okay, that is one of the most important concepts of this unit, because this is what people tend to mess up. When I multiply, notice I never even mentioned a common denominator. When I multiply, I just multiply. Okay, I simplify and then I multiply. When I'm talking about common denominators, I'm talking about adding and subtracting only. Okay, when you add and subtract fractions, you must have a common denominator. Only with adding and subtracting. Okay, if I do it with the multiplying, I'm going to get a common denominator, which I'm going to turn around and I'm going to reduce right back out of it, so it's a waste of time. Okay, so when I'm doing adding and subtracting, I must have a common denominator. Okay, so looking at the rule, if I have a over b plus c over b, notice they're exactly the same. Okay, then I add the tops together, keep the bottom the same. Okay, go back to things that you know very, very well. Okay, an example of that would be if I have 1/2 and I add another 1/2. Okay, hopefully we can all do that in my head. 1/2 plus 1/2. Okay, we're going to add the tops together, keep the bottom the same, because 1/2 and another 1/2 makes 2 halves, or just 1. Okay, and you should be able to do that kind of math in your head. So if you find yourself getting stuck on these rules or confused on the rules, go back to things you know. You know that 1/2 plus 1/2 makes 2 halves. Okay, it doesn't make 2 fourths or anything like that. We know that 1/2 plus 1/2 makes 2 halves. Okay, 1/4 plus 1/4 makes 2 fourths. Okay, and that's how that works. So go back to the basics. Go back to things that you know for sure to help you with these rules. So 2 over 2 is 1. Subtraction rule. Okay, subtraction rule, same sort of thing. When I have a over c minus b over c, that's going to be a minus b over c. Okay? Oops, sorry. And it doesn't matter which order I put these things in. Let me just show you, because I think the notes that we'll do in class actually have the letters like this, and I apologize. Okay, but it doesn't really matter. If I have a over b minus c over b, that means the exact same thing as what I just talked about. We'd have a minus c now over b. Okay, the important part is that I have the same denominator on both, so they both have a b on bottom. And I'm going to subtract the top a minus c, and I keep the denominator the same, so we get a b on bottom. Okay, so again, if I have, I don't know, let's make this easy. If I have, we'll just do the same one. If I have 1/2 and I take away 1/2, I should get 0, right? Okay, 1/2 minus 1/2 equals 0, because I had a half and I took away a half. Now I've got none left. And the reason why is because I get, let me write it out, 1 minus 1 over 2, which is 0 over 2. Okay, 1 minus 1 over 2, which is 0 over 2. Okay, so that's our rule there. So let's go ahead. These say add or subtract right in lowest terms. Now here's something super important. You cannot simplify adding and subtracting until after you have put them together. Okay? When we looked at multiplying, we are allowed to simplify first. Okay? Multiplying, dividing, you simplify first. Adding and subtracting, you have to simplify after, because we need this common denominator. Okay? So here, 2 sevenths plus 4 sevenths, sorry, a little crooked there. 2 sevenths plus 4 sevenths, you just add the top. 2 plus 4 over 7 is 6 over 7. Okay? I know I can't break that down because 7 is a prime number already, so 7 will not break down, so that's just going to be my answer. That is my lowest term. So same thing here. Now it's 7 tenths minus 2 tenths, so I get 7 minus 2 over 10. equals 7 minus 2 is 5, okay, over 10, which I know reduces to 1/2. Now again, if you need to, okay, you can always break these down. 5 is already prime. 10 breaks into 5 and 2. Okay, so when I reduce, the 5's go away. Remember I said even if the entire numerator gets canceled, you have to put a 1 in its place. So I get a 1 on top to hold the numerator spot, and a 2 is left on bottom, so 1 over 2. Okay, same thing here. So 2/5 plus 1/4. Now this is a little bit different because I can't just go from right here. Okay, 2/5 plus 1/4. I have to have a common denominator. Okay, so you have to think between 5 and 4, okay, since these things are not the same, I need a common denominator. So what does both 5 and 4 go into? Okay, well the common denominator there, which we should be pretty good at finding, is going to be 20. Now keep this in mind too. It just has to be common. It does not have to be the least common. Okay, least common makes my number smaller, makes my life easier, but if I cannot find the least common denominator, then I can always multiply these two things together, and that will give me a denominator, okay, a common denominator. I know that if I multiply 5 times 4, that gives me 20, so 5 goes into 20 and 4 goes into 20, because those are both factors. Okay, so if I can't find a least common, at least multiply them together and get a common denominator. Okay, it will still work, you'll just have to reduce more. So what that means here is that I've got a 5 on bottom. I have to think, what do I multiply 5 by to get me to 20? And it's going to be a multiplying thing. Okay, we're going to multiply to get a common denominator, because if I multiply the top and bottom by the exact same number, then I have it change the value, because I'm really just multiplying by 1 in general, and I'll show you what I mean. So if I multiply 5 times 4, that would give me 20. So if I do it to top and bottom, well, now I've just multiplied in a 4 over 4. Well, that's multiplying in a 1. Okay, well, 1 times anything is still itself. So I haven't changed the value, I'm just changing the way it looks. Okay, I'm going to do the same thing for this one. So to get a 20 out of a 4, I'm going to multiply by 5. Okay, and I'm going to do that top and bottom so that I'm really just multiplying by 1. Okay, from 5 over 5 is 1. So what that gives me, 4 times 2 is 8. 4 times 5 is 20. 1 times 5 is 5. 4 times 5 is 20. Okay, so now I have a common denominator. And once I'm here, now I can go ahead and add these things. So 8 20ths plus 5 20ths, 8 plus 5 over 20. Notice I didn't change the denominator. It stays the same. 8 plus 5 is 13 over 20. The way I've always thought about it, to remember when to change the denominator and when not to, is I did all that work to get a common denominator. Why would I change it? Okay, I worked really hard to get a 20 down here, so it's going to stay a 20 all the way to the end until I reduce my very last fraction. 13 is prime and it doesn't go into 20, so that is my answer. Nothing's going to simplify. Okay, so same thing's going to happen with the subtraction here. Okay, we're going to have to do common denominator first. Okay, so find a common denominator first. So between 10 and 6. Now again, if you can't find the least common denominator, then just give me a common denominator, okay? So 10 and 6, I can always do 10 times 6, or I can do common denominator, which I'm going to do CD. 10 and 6 both go into 30. Okay, so that would be my least common denominator, is actually 30. But again, if I can't figure that out, 10 times 6 is 60, and 60 would work as well. Okay, so either way. So if I'm going to go with 30, then I'm going to multiply the bottom by 3, top and bottom by 3 in the first fraction, and here top and bottom by 5. Okay, because 5 times 6 is 30. So I get 9 over 30 minus 5 over 30. Which is equal to 4 over 30. Okay, 9 minus 5 is 4, which can actually simplify. So if I break this down, 2 and 2, and I break this down, that would be 15 times 2. Okay, and 15 breaks into 5 and 3, so I can get rid of a set of 2's. So final answer here would be 2 over 5 times 3 is 15. Okay, so 2/15 would be my simplified answer. Okay, I want to show you really quick, just as a side note, if you had done the 60. So if I'd have done 60, I had 3/10 minus 1/6, and I did a common denominator of 60. Well, that means I would multiply this by 6 top and bottom, and this by 10 top and bottom. Okay, well when I did that, I would get 18 over 60 minus 10 over 60, which is going to equal to 8 over 60. Okay, now that 8 over 60 needs to reduce. Hold on, my screen froze again. It's going to happen at least once per video. Okay, so that 8 over 60 is going to reduce. So that 8 breaks into a 4 and 2, 2 and 2. Sorry, I'm getting a little messy here myself. 60 breaks into 30 and 2, 15 and 2, 5 and 3. That's a 5 and a 3. So now go through and cancel everything. So I've got a 2 on top, 2 on bottom, 2 on top, 2 on bottom. I'm left with a 2 on top and a 5 times 3 on bottom, which is 15. So it simplifies out to the exact same answer. 2 15s and 2 15s. The only difference being is that this one had some extra 2's in there because I did by 60 instead of by 30. So it will work if you just multiply the bottom two together. You just might have to reduce more. Alright, so I wanted to show you that just so you know that they do work out. Alright, so the next one. Now I've got 3 of them. First of all, when you're adding and subtracting, you're just going to work left to right. Okay, order of operations, you just work the left to right, but first we need that common denominator. So now I have 3, so I have to find a common denominator across all 3. So I'm looking for what number does 2, 22, and 11 go into. So the common denominator there is 22. Okay, so this first one I can multiply by 11 to get 22. The second one is already done, so don't do anything to it. If it already has the common denominator, just leave it alone. Okay, so 17 and 22 is already there, and I can multiply this by 2 and give me 22. So I end up with 11 over 22 plus 17 over 22 minus 4 over 22. Okay, now just put those together. 11 plus 17 is 28 minus 4. Actually, let me write this out for you. 11 plus 17 minus 4 all over 22. Okay, denominator stays the same all the way across. So that would be 28 minus 4, which is 24 over 22. Never leave it. You got to reduce. 12 and 2. This would be 11 and 2. Now I'm going to go ahead and stop there. So this is kind of where that shortcut starts to come in. Okay, I know that 11 is prime, and 12 is never going to break into 11, so the 2's can go, but that's the only thing that I'm going to be able to cancel. I'm going to have 12 over 11 left, because that's prime and it doesn't go into 12. So it makes my life a little bit easier if I start to recognize things like that. Okay, now there's 2 on your owns on there, and this is the end of this little section. So please, oh, maybe it's not the end of the section. No, not the end of the section just yet. Okay, so hit the pause button. Okay, try those 2 on your own. Come back. We still have another little section to go where we talk about our mixed and improper fractions. Okay, hopefully you tried these. This first one should have been super easy. It is already set up. 1/5 plus 3/5 makes 4/5. 5 is a prime number and it doesn't go into 4, so that is your answer. That should have been done in about half a second. Okay, this one on the other hand takes a little more work. First I got to figure out my common denominator. Okay, well 3 goes into 21, 21 obviously goes into 21, and 7 goes into 21, so 21 is my common denominator. And again, if I can't figure that out, I could always multiply all 3 of these together and it'll work. It's just going to be really big numbers. Okay, I wouldn't suggest it. I would say try to find your least common, but if you can't figure out the least common denominator, please just multiply all the denominators together and that'll give you a common denominator. Okay, it'll take you a little longer, but at least you won't lose points. Alright, so to get 21, we multiply by 7 top and bottom here. Okay, that we leave alone. Here we multiply by 3 top and bottom. So I get 7 over 21 plus 8 over 21 minus 6 over 21. Okay, so we got 7 plus 8 minus 6 all over 21. Okay, I like to put them all together just because it makes it easier for me. 7 plus 8 is 15, minus 6 is positive 9 over 21. Now we simplify. Notice I never simplify till I get to the end. 9 breaks into 3 and 3. 21 breaks into 7 and 3. So I can get rid of one set of 3's, and I'm left with 3 over 7. Sorry, I should have gotten rid of those. 3 over 7, final answer. Okay? So hopefully you got those correct. If not, you can go back and try them again and see if you can't get the right answer. You can always get online and pull up all kinds of fraction worksheets. Just Google free fraction worksheets, and you'll have lots of practice. They usually have answers to go along with them. Alright, so now the last little part here is the mixed and improper fractions. Okay? You have to be able to work with mixed and improper fractions. So what are they? Proper fractions, let me get you lined up here. A proper fraction is a fraction that's numerator is less than the denominator. Okay, those are considered proper fractions. So like 2/3, 4/5, 7/10, stuff like that. Okay, the bottom is, or the top is smaller than the bottom. So the numerator is smaller than the denominator. Those are proper. Okay, a mixed fraction is when you have a whole number and a proper fraction combined. Okay, notice that it says a proper fraction, so like 1 1/4. Okay, we've got a whole number and a proper fraction. 3 2/5. Proper fraction. Okay, they can be negatives, it's fine. -4 1/8. Proper fractions. Okay, proper fraction here, and then there's a whole number. That makes this a mixed fraction. Okay, improper fractions, okay, you're going to have the top is bigger than the bottom. So like 4/3 is improper, 7/2 is improper, 10/7 is improper. And you're going to have to give me just a second. Super apologize, but I have to take ADA attendance. Yes, I am in a school day on my conference right now. Okay, apologize for the delay. Okay, so the improper fractions, top is bigger than the bottom, that's all it is. Okay, so when you're looking at these things, we have to be able to convert from mixed fractions to improper fractions so that we can utilize our rules on these. Okay, so for instance here, okay, if I want to convert, now a lot of people call this the Texas thing, okay, Texas thing. So what happens is we're going to start off by multiplying. Now we are going to start on the bottom. So 3 times 4, okay, gives me 12. So 3 times 4 here gives me 12. And then we're going to add. So then you take that number and you do 12 plus 1 gives me 13. Okay, so you end up with 13 over the original denominator, which is 3. Okay, let me show you that one more time. So we did multiply, so multiply here. Again, we call it the Texas. So 3 times 4 is 12, plus 1 is 13. That's your new top. Bottom stays the same. Okay, let me show that to you one more time. So here we go. So Texas. Multiply first. 21, okay, plus 2 is 23 over 7. Okay, bottom just stays the same. So 21 plus 2 is 23. Okay, so 21 plus 2 is 23. So 23/7 is how you convert this mixed fraction into an improper. We're going to do that most often because we want to put things in improper fractions so we can add, subtract, multiply, and divide. Alright, so then converting from improper fractions to a mixed fraction. So if they want you to put it as a mixed fraction in the end, then we can convert it back. Okay, so to convert it back, you're basically just doing the opposite order. So here, and I'm going to take you way back to like 6th grade, depending on how old you are, 5th grade, somewhere around there. Okay, and to convert back, you just divide, because we multiplied and then added. So here I'm going to divide and then subtract. So I'm going to do a little long division, okay, because that's exactly what that means. 15/7 means how many times does 7 go into 15? So 7 goes into 15 twice, so that's my whole number, because it goes in 2 whole times. Okay, and I have 1 piece remaining. Okay, so my mixed fraction would be 2 whole numbers with 1 out of my 7 pieces. Okay, so 2 whole pieces with 1 remaining out of the 7 pieces. Okay, so that's how you convert back. Okay, so let's look at that one more time. So 3 halves. Okay, so if I have 3 halves, so I would just go 2 divided into 3, so 2 goes into 3 once. Okay, and I do 1 times 2 is 2, we subtract, 3 minus 2 is 1. So my answer would be 1 whole. Okay, this is my numerator, and this is my denominator. Okay, so we have 1 out of 2 left, which hopefully you can recognize. 3 halves, if I have 3 halves, that's 1 and 1 half. Okay, think about 3 halves of a pizza put together. You would get 1 full pizza and a half a pizza. Okay, so 1 and 1 half. Okay, sorry about the bell. Alright, so now the very last section, finally, operating with mixed fractions. So whenever I go to operate with these things, I want to first convert them. Okay, so convert first. That is my suggestion to you. Okay, there are many other ways, and if you are comfortable enough, I can change just this, and I can work with whole numbers and fractions all at the same time. There's nothing wrong with that. I am not going to do that. I'm going to keep it as simple as possible, and I'm going to do the same thing every time, so I'm going to convert first. So 6 times, so Texas, here we go. 6 times 3 is 18, plus 1 is 19 over 6, minus 12 times 1 is 12. 12 plus 11 is 23 over 12. Okay, 12 times 1 is 12. 12 plus 11 is 23, and it's over 12. Now, I am subtracting fractions, okay, which hopefully you immediately recognize means common denominator. Okay, let me kind of write it right here. So here we convert, okay, and then we common denominator. Okay, so common denominator here is going to be 12, right, because 6 goes into 12, so times 2 top and bottom here. Okay, that would give me 38 over 12 minus 23 over 12. Okay, so that's that step, is common denominator, which is going to be, when you subtract that, I get 15 over 12. Okay, so 38 minus 20, or 38 minus 23 gives me 15. 15 breaks into 5 and 3. 12 breaks into 4 and 3. Okay, 5 and 4, those are going to be 5 is prime, so nothing's going to cancel with it. So I'm left with 5/4 as my answer. Okay, left with 5/4 as my answer. So I'm going to do that same sort of process every single time. We're going to convert. If it's adding and subtracting, we're going to common denominator, and then just put them together. Okay, and then it's like every other one that I've done. So I want you to hit pause if you feel comfortable, okay, or as soon as you feel comfortable, hit pause and give these other ones a try. Come back, see if you can get the same answer as me. If you don't feel comfortable yet, then keep watching until you do, okay, but I would suggest that you try some of these on your own. Okay, so here we go. I'm going to keep on going. Okay, 3 times 8 is 24, plus 1 is 25 over 3. 10 times 2 is 20, plus 7 is 27 over 10. Okay, so I'm going to need a common denominator here, so common denominator is going to be 30. Okay, that's what both of those go into. So here I'm going to multiply by 10 top and bottom. Here I'm going to multiply by 3 top and bottom. Okay, so 10 times 25 is 250 over 30. Okay, here I'm going to get 27 times 3, which is going to be 81 over 30. Okay, add those together, and I'm going to get 331 over 30. Okay, now these I can combine, I can go back to a mixed fraction, and I forgot to mention that on this first one here. I can take this back to a mixed fraction, okay, so I could do 4 goes into 5 once with 1 remaining. Okay, I can do the same thing here. So this can also be 30 goes into 331. I'll do it off to the side so you can kind of see it, in case we've forgotten how this works. 30 goes into 33 once. Subtract. You get 3, bring the 1 down, so you got 30 goes into 31 once, and I'm going to have 1 remaining. Okay, so I'm going to get 11 as my whole number, and I've got 1 out of 30 left. So 331 over 30, or 11 and 1/30 would be my answers there. Okay, so I've got 4 and 6/11 minus 3/11. Okay, again, we can do our converting, or you can just go from here. Now, a lot of you guys are going to see 6/11 minus 3/11 is just 3/11, but I'm going to show you with converting just in case you don't see that. So 44 plus 6 is going to be 50 over 11 minus 3 over 11, which is going to be 47 over 11, which when I convert back, 11 goes into 47 4 times with the 3 remaining. So we would get 4 and 3/11. Okay, some of you guys might have seen that right away, which is perfectly fine with me. If you didn't, you can convert. Okay, I'm going to keep showing you the conversion just because it stays uniform and you can see it every single time. Alright, so D. 5 times 4 is 20. Okay, I'm not going to multiply my line like this, because if I do, I have to distribute. I have to do 4 times 2 and 2 times 3/5, and that's just too much for me. I will convert every time. 5 times 4 is 20, plus 3 is 23 over 5, times 2. Remember, anytime you have a whole number, I can throw it over 1. This is multiplication. No common denominator needed. I hope you caught that. 23, because if you do common denominator, you just made stuff way bigger than you needed to. Okay, 23 times 2 is 46 over 5. 5 is prime and it does not go into 46, so that would be your answer. Or, change it to a mixed fraction. 5 into 46 goes 9 times. 9 times 5 is 45. Subtracting, we have 1 remaining. So you would get 9 and 1/5. So 46/5 or 9 and 1/5, and you need to be able to do both, okay? You do need to be able to do both. You need to be able to change these back to improper fractions, so keep that in mind. So same sort of thing here. I'm going to convert. I am not going to multiply like this. I don't like to. Okay, 6 times 5 is 30, plus 5 is 35 over 6. Okay, multiplying. There's nothing that this is going to break down to, because this is going to be 7 and 5, so nothing cancels whatsoever, so it's just going to be 35 over 24. Again, I say nothing cancels because here, when I break this down, I get 2 and 2, 3 and 2, so nothing there is going to cancel out, so I just get 35 over 24, which would reduce to...
Good morning, Eagles.
24 goes into 35 once. 1 times 24.
Flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now the Texas pledge. Honor the Texas.
I'm going to go ahead and write out this last one, but I'm not going to explain because they're doing the pledge.
One state, under God, one indivisible. Please remain standing for the moment of silence.
Don't forget to KFC. I have to flip that.
You may be seated.
Students know that they will be moving over the summer and will not be returning to aid.
And that's it.